Well, according to our guest, Michael Brooks, science's best-kept secret is simply this. Even today, there are experimental results and reliable data that the most brilliant scientists can neither still explain nor dismiss. Basically, 13 things that just don't make sense. His book. We'll be back in a moment on Coast to Coast AM. And welcome back to Coast to Coast. I'm George Norrie with Michael Brooks. Michael's a journalist, author, consultant at New Science. He's also co-writing a very major TV series for Discovery Channel, exploring the known universe through the eyes and imaginations of Professor Stephen Hawking. Here he is, Michael Brooks. Hey, Michael, how are you?
I'm very well, thank you, George.
Good. Stephen Hawking is just a remarkable man.
He absolutely is. I mean, it's an incredible kind of journey that he's been on since his younger years. It's extraordinary.
How's he feeling, Michael?
Well, as far as I know, he's kind of carrying on as before. I mean, he was predicted to have died by the time he was kind of 21, 22, and he's made it through all this time. I think he's in his sort of late 60s now, so I think he's feeling pretty good. I think he's feeling on top of the world in many ways.
That's great. 13 things that don't make sense. What makes sense these days anyways, Michael? Everything's up and down, isn't it?
Well, that's right. The world is a kind of crazy place these days, isn't it? But
yeah.
I mean, this is kind of to do with science. So I've limited myself. A number of people who said, "Well, I've got a few things in my life that don't make sense."
Tell me a little bit more about yourself, Michael.
Well, I'm a quantum physicist by training. I did a PhD in quantum physics, and I've sort of spent the last few years working for New Scientist magazine in the UK as a writer and editor. Consultant, I get to go to scientific conferences. I get to travel around, talk to the biggest scientists in the world, really. So it's a great position to be in.
I think the best physicists out there are the people who, like Hawking, like Michio Kaku, who explain the science of physics in such a way that we can all understand.
Do you know what? I think I agree with you completely. I think it's the most important thing a scientist can do is actually communicate what it is that they're actually working on. And interestingly, there's a guy called Erwin Schrödinger, who you may have heard of, Schrödinger's cat. Yeah, I mean, he said that was back in 1950. He said that if you're working on something you can't explain to anyone else, then just stop working on it because it's not worth doing.
That's so true. That is absolutely true. We do that too with our producers. They come up with a subject, and I say, "All right, what does that mean to us?" And if they can't explain it to me, it's not worth a show. And this one was fun for me because I love science, but more importantly, I like your approach to this thing.
Okay.
And we'll have some fun tonight.
Okay, good.
You're out there where? In the United Kingdom, aren't you?
I am. I'm in the south of England.
Hey, what's the perception out there, not to move on for a little bit, but
yeah,
the way things are happening with Russia and Georgia and everything, what's the perception out there in the UK about all this?
I think people are feeling pretty fragile, to be honest. I think there's a sense that, the whole Cold War thing went away and we all started feeling quite secure. And it just shows you how the world is balanced on a knife edge, really.
Yeah, I think so, too. I mean, are people tense there? Do they expect something bad to happen?
I think nobody knows quite what to expect. I mean, we're kind of hoping that Georgia is small enough that it won't cause a big fuss worldwide. But, people are starting to square up to each other. And there is a sense that this could go quite badly. Something
happened to the Russians all of a sudden. I mean, they just woke up and decided, we're going to stand our ground this time. And, whether Georgia started it or not, the point is the Russians now are saying to us and Poland, we're not going to accept this missile defense pact you've signed.
No,
and,
right.
If you start putting these missiles in, things will get out of control militarily, paraphrasing. Man, it just feels strange, So when you talk about things that don't make sense, this whole thing doesn't make sense.
I think that the situation there is just so volatile. It really could go either way. But, people thought Russia was kind of tamed or something, didn't they?
Yeah.
And I don't think that's the case at all. And I think, there's enough money there and there's enough power for the people who have the money, that, we're in a very dangerous situation.
I think so too, Michael. I really do. Tell me about the approach, 13 Things That Don't Make Sense. How did you come to this?
Okay, well, the idea was basically, quite often at the magazine I work for, New Scientist, quite often we'll talk about the latest results in science. We'll talk about what scientists have achieved. And I just kind of came up with the idea, well, why don't we talk about what science hasn't achieved for once? Why don't we actually look at the things that they can't explain? Because surely these are like the most interesting things. And I did a bit of digging into it, and it turns out that pretty much every kind of major revolution in science has been brought about because something didn't make sense. When Einstein discovered relativity, there were results around that nobody could make sense of, and he put them all together and came up with relativity and explained all these anomalies. So the idea was to say, well, if that's happened in the past, surely it could happen again. And thus was born the idea of actually looking across science and seeing what might be coming next by looking at what doesn't make sense today.
Michael, scientists generally are looked at in society as being, these incredible minds. They've developed things that have helped society. They've developed things that have hurt society as well. Yeah. How are they being looked at nowadays?
Well, it's an interesting question because, on the one hand, there's some skepticism and there's some kind of sense that scientists might be running out of control. You have the issue of genetically modified crops and things like that, which are a big problem over here in Europe, actually, and people are very skeptical about them. There's the sense that science is just almost becoming too powerful. And yet, at the same time, of course, everybody welcomes the technologies that science brings to us. So from our non-stick pan to Velcro, whatever, science and scientists' products have become an everyday part of our lives. And so there is a sense in which, we're kind of letting scientists, go on a leash, I guess, and sort of reaping the benefits of what they do. And yet there is always some unease about, what scientists are capable of doing and who's making sure that they're doing the right thing rather than the wrong thing.
Do you think science is right most of the time?
Yeah, I do. I actually, I'm a big fan of science. You don't get me wrong on this. And I think it's achieved incredible things. And it has this weird self-regulating system. It's unlike politics. In that it just seems to kind of regulate itself pretty well. And most working scientists are not looking to take over the world. They're just kind of motivated by their own curiosity. And so what you have is a bunch of people who are actually, not bad at doing the right thing. Although sometimes, these issues become contentious and nobody quite knows what the right thing is. But on the whole, I kind of think science is a strong force for good.
Let's talk about some of these 13 things that don't make sense. And you've kind of outlined them very well in your work here, in your book. But you talk about the missing universe, Michael, where science can only account for 4% of the cosmos. Yeah. Where in the heck is the other 96%?
Isn't it extraordinary? Every time I hear that statistic, I just can't quite believe it. Basically, what we have, the stuff that you and I and the chairs we're sitting on are made of, atoms, atoms and the stuff that makes up atoms accounts for 4% of what we know to be in the universe. And basically, scientists can kind of weigh the universe using various tricks that they have. And they find that there has to be more matter out there than we can see. So there's some kind of matter out there, which they call dark matter, which makes up about 25% of the universe. And nobody's ever seen this, and nobody knows what it's like or what it does. Nobody knows even what to call it. That's why it's just dark matter. And then what we have is around 70% of the universe is made of a kind of energy. Now, you might know from Einstein's equation E equals mc squared that energy and mass can kind of transform into one another. And so what we have is this energy, which they just call dark energy, which seems to be ripping the universe apart. It's making the universe expand faster and faster all the time. And scientists are fairly sure that this is out there. They have no idea what it is, where it comes from, or what it might do in the future.
Do you think the universe is expanding, contracting? There are different theories about that.
Well, the scientific viewpoint is that the universe is expanding, and it's expanding faster and faster, which actually came as a huge shock when this was discovered. I mean, first of all, back in the 1920s when we discovered that the universe is expanding, that was a shock because the whole point was, there was a big bang and so it kind of expanded out and it should have been slowing down. So the idea that it's speeding up is just extraordinary.
See, I'm trying to just picture what's it expanding into? What is it speeding up into?
Well, what a great question.
What's on the other side?
We have no idea. I mean, all we know is that we have, space that we move around in and time that seems to move. And Einstein pulled them together into, one thing with 4 dimensions. So we have 3 dimensions of space, 1 dimension of time that we live in. And we have no idea what's beyond that. So when we talk about the universe expanding, as you say, the space that we perceive as our universe is getting bigger and bigger. But actually, we don't know what's on the other side. What is it expanding into? Not a clue. We just don't have any tools to look at that at all.
Parallel universes? What do you think?
Well, it's entirely possible. And there's many kinds of parallel universe as well that science offers. And these are taken very seriously, actually. There's the parallel universes that quantum theory throws up as the idea that, when a quantum particle has to choose between one of 2 doors, it takes both, but one of them's in a parallel universe. And the extrapolation of that idea is that somewhere in another universe there's another copy of you, George. So,
yeah.
I mean,
God help us.
Well, you know what? I don't think he can get to us, so I think we might be all right. But and then there's the parallel universes. The people think that beyond our universe there may just be millions and millions of other universes that maybe are like ours and maybe are slightly different, and that's a very mainstream thought in physics these days.
Maybe black holes connect us to these other universes.
That's another suggestion that's been made, and I know Stephen Hawking did some work on this. The idea that if you fall into a black hole, maybe, just maybe, if you can survive it, then you'll end up in another universe. I mean, and that's an idea that has been out there for a while, and nobody's disproved it. And we certainly don't know what happens at the end of a black hole. And I'm not volunteering to find out.
I had to give a couple speeches this past weekend. And so as I'm driving to this location, which was 3 hours away from Los Angeles, where I am now,
yeah,
we're driving alongside the Pacific Ocean. And I'm just looking at this portion of this body of water, saying how huge it is, just how immense it is. And then I'm trying to visualize the size of the planet in terms of, to me, how astronomically huge it is. Yet it's only a small speck, Michael. That's it.
That's it.
And
I mean, it's a thought that it's kind of everybody should wake up to it at one point in their lives. That we're just an insignificant speck in this cosmos, and that's an extraordinary thought, really. And like you, I look at the ocean and I just think, wow, it's just incredibly vast. And at the same time, I kind of think, well, at least I'm aware of it. I'm something in this universe, at least, because I can have these kinds of thoughts. And that's the kind of comfort that you can take in this idea of our insignificance. Our insignificance is extraordinary, but so is the fact that we can kind of perceive of it. The idea that we can map the universe. I mean, isn't that amazing?
Sure. Do you accept the theory of the Big Bang?
Yes, I do. But I don't think the book is closed yet. I think there are problems with the Big Bang Theory.
What would the problems be?
Well, one of the problems is a thing called the horizon problem, where physicists kind of measured the kind of temperature all the way around the universe, like where it is. And basically, the temperature of the universe is the same everywhere. And the point is that when the Big Bang happened, it was a massive, chaotic explosion kind of event. And so you wouldn't expect it to be so uniform. You'd expect the universe to have kind of developed regions of different temperature, because there's no way for the temperature to equal out, once it gets to a certain size. Because for temperature to even out, you've got to have exchange of heat. And when two things are so far apart as opposite sides of the universe, they can't exchange heat. And so this was a big problem for a while. And then somebody came up with an idea called inflation. And inflation basically says, well, just after the universe was created, it suddenly blew up really, really fast and really, really big. And just before that happened, all the temperatures equalized out, and that was fine. And that's why we see this uniform temperature across the universe today. Now, that's a great idea, and it's still like the best idea we have for explaining this, except that nobody has any clue as to why this should have happened or how it might have happened. So it literally is just a conjecture that's pulled out of the air. And, we're 2 decades into trying to find an answer to those questions of why and how inflation might have happened. And nobody's any the wiser, to be honest, and people are starting to give up on the hunt. So, there's a big problem.
Well, they may have to give up on the hunt because there may be no answer.
Well, that's always the danger, isn't it? And that's the thing scientists live with in the back of their minds the whole time, is that some questions we just may not be able to answer. People ask the question, what was there before the Big Bang? And that's a really difficult one for science to answer, because you kind of think, well, before implies a notion of time. And, of course, scientists believe that time came into existence with the Big Bang, so there was no before.
And what was nothing, How,
well, quite.
How can you explain nothing?
We're sort of straying into philosophy here, aren't we, really?
Yeah, they do merge. They really do.
At this stage, it's hard to tell them apart, to be honest.
The other... one of the other things that you say don't make sense, the Pioneer anomaly. We've talked a little bit about that on this program before, about the 2 spacecraft that are continuing to change the laws of physics, and we don't understand what's going on there. Is it possible that there's some huge object that was outside of our solar system that could be affecting them?
It is possible. The trouble is, if there was some huge object whose gravity was pulling them or something like that, you'd expect it to have other effects on things in the solar system. And at the moment, our calculations of how everything behaves are absolutely bang on the money. And, how the planets move, how their moons orbit. We can work out the timing of eclipses, with incredible accuracy. And you sort of think if there was something else out there that's that big, then maybe we would have seen it in other data. Having said that, you see, people have kind of conjectured the idea that there's another planet out, sort of way out in the...
Planet X.
Yeah, that's right, Planet X, way out on the edge of the solar system. And there's some sort of evidence that makes this quite a compelling idea. And so who knows? I mean, we've never actually seen a good photo of Pluto. Have you ever seen a good photo of Pluto?
No,
it's like this blurry kind of little mess
thing,
that you see. Yeah. And you realize that that's kind of pretty much the limits of what we can see and what we can know in those terms. So nothing can be ruled out there, I would say.
Pluto the planetoid, I guess, huh?
Yeah, that's right, yeah. Poor little Pluto.
The other area, varying constants. What do you mean by that?
Okay, this one I find really interesting, and it's a little bit kind of maybe more abstract than the others. But the idea is, we have these things called the laws of physics, that are constantly referred to in Star Trek, for instance. The idea of the laws of physics. And what we mean by that is that, we know how things behave, and we pretty much, have it pinned down how they behave. And so we shouldn't be able to, see variations in behavior that kind of contradict those laws. But those laws are kind of upheld by these things called constants, which are numbers that we just plug into the laws to make them work, to reproduce the things that we see. And these constants are meant to be constant. They're not meant to vary in time. If one of the constants, for instance, is called big G, the gravitational constant, which is what holds you down on the Earth. And it kind of tells you how strong gravity is. And the point is that should be the same now as it was 10 million years ago. I mean, there's no reason for gravity to change, except that in some of the constants, and one of them is called alpha, and it determines how light and matter interact in the laws of physics. There are hints from astronomy that the alpha was different in the past. Not hugely different, but different enough that if it were that different today, it would affect the way all kinds of processes go on Earth. And so, this is a kind of real sacred cow. The constants of physics are supposed to be constant, and yet we have these tantalizing hints that they're actually not.
We're going to take this break, Michael. We'll come right back with you as we continue talking about 13 things that don't make sense. We're going to get into the possibility of alien life. Alien life. We'll be back. And we're with physicist Michael Brooks. He's live in the United Kingdom. I'm right here on the West Coast. We'll be back in a moment on Coast to Coast AM. Let's move on, Michael, to another area that doesn't seem to make sense.
Okay.
Cold fusion.
Hey, this is a real favorite of mine, actually, just because it really kind of shows science at its best and at its worst, I would say. Cold fusion is the idea that you can get energy from something like seawater, basically. You can release the energy that's locked up in the nuclei of seawater. And, of course, in 1989, this was big news when a couple of researchers from the University of Utah announced that they could do it. Ever since then, it's been a kind of byword for bad science, I would say.
Michael, life as we know it, I think, is teeming throughout the universe. No proof of that yet. It's just a belief system I have. How about you?
I agree with you. I can't see any reason why it wouldn't be. I mean, this is the kind of prejudice that we have is that we're somehow special and that Earth is somehow this special place. But as we've already talked about, the universe is this vast place that we have really no conception of. And why should we be the only place in this whole universe that has life? It doesn't seem sensible to me.
It doesn't seem sensible, and I think one day science will figure it out, and a lot has to do with the propulsion system and how they get here and how we get there one day. But there's got to be billions of civilizations like ours. It'd have to be. I think the seed's the same.
I can't see any reason why there wouldn't be. I mean, the only possible explanation that you can have for why there wouldn't be life elsewhere, teeming in the universe, is that somehow there is something intrinsically special about human beings.
Have you come up with a definition on just what is life?
I haven't, and nobody has. It's one of those things that scientists are actually starting to say, let's stop trying to define life because, we've been trying to do it for half a century now and we're getting nowhere. Every time they come up with a definition, you can find something that actually does that, but nobody would call alive. So it's a bit like art. You kind of have a gallery owner who owns this gallery, and he says, he can't define what art is, but he can define what he's willing to put in his gallery.
If you're spiritual, then you'll say that life is just a process of, reaching perfection to join the other side, to, whether you get to heaven or whatever you want to call it.
Yeah.
And it's just we're here to learn. It's an experience for us. If you're spiritual. If you're not, then you have to come up with some rationale why we're here.
That's right. I mean, I think if you're not spiritual, then I think the only sensible position to take is that life must be everywhere and that it's just something that happens, follows the laws of physics, if you like.
Do you think, though, the laws of physics just happened or that they were created?
Well, the laws of physics as we have them just describe how the universe works. So it's kind of our way of describing how the universe works. I mean, we're coming down again to this whole idea of why does the universe even exist in the first place, and where is this universe? One of my favorite theories about this is that everything kind of becomes explained if you think of us as some kind of computer simulation, like, as if we're living in Second Life.
I kind of look at it like this. If you have a car that is parked downhill, and you pull the emergency brake off, you turn the engine on, you put it in neutral, and you let it go, you're not in it. That car is going to just weave and all over the place, and eventually it'll come to some crashing end.
Yeah.
And, because it's not under direction, it's not under control. And if you were sitting in that car, on the other hand, you'd be able to steer it right down the hill and make your turn, and off into the road you go, and, away you go.
Yeah.
Under control. I kind of think the universe is like that something has steered it in a direction under some form of guidance.
Yeah.
And it's going somewhere. It's doing what it's supposed to do under direction, because without the direction, it would be scattered everywhere. And I just can't believe that there's so much order in the universe and it wasn't put there by design.
It's certainly a perspective that many scientists share. The only way of looking at it, in a sense, is that we don't have all the answers to questions like this because science just doesn't have the tools to investigate them. But what we can say is, if the universe was any different, and if it wasn't, didn't have this kind of sense that there was control and there were laws and that it was behaving in a way that allowed us to exist, then of course we wouldn't be here to observe it. So this is, in fact, the only kind of universe in which we could exist.
No doubt about that. And you know that they think they found life on Mars during the Viking mission, but then NASA changed their mind.
Yeah, I do.
You're right about that.
Do you think I'm right about that?
No, yeah, and you do. You're right.
I'm right about it. Yeah,
and you may be right about that.
There's a big part of me that thinks I am right about this. And the guy who made the discovery, a guy called Gilbert Levin, he just retired last week. I think he's in his late 70s now, and he's been kind of just really shamefully treated throughout his career, I would say.
Because of this?
Because of this, yeah. Because, I mean, he initially accepted that NASA had made this decision that his experiment didn't detect life because some other experiment said there was no life on Mars, or there were no carbon molecules on Mars from which life could be constructed. But, I mean, we've since found out that this second experiment was, not working and not sensitive enough to detect those carbon molecules. And so, this guy, Gil Levin, has spent his whole life, kind of trying to convince people that it's worth a second look. He never said, okay, I did it, but he said it's worth a second look, surely. And he ended up, not even being invited. I think it was the 10th anniversary of the Viking mission. They had a big party, and he wasn't even invited to go along to that, which I think is just outrageous.
Well, why does it seem that NASA does not want us to know about this?
That's a good question. I think NASA has kind of, ever since the Viking mission, NASA has avoided looking for life. And now, if you look at all the missions that have gone up, they look for signs of things that could be conducive to life. They really kind of hedge their bets, which I just think is a shame. We've already discussed, how important it would be to kind of understand whether there's life elsewhere in the universe. And it seems that it's just so contentious, and almost the stakes are so high that they almost don't want to make any kind of foray into looking for life. And so they'll look for water, and they'll look for signs of water on Mars, and they'll look for certain types of chemical. But I guess, and you could argue that nobody knows what life is, therefore, let's not look for it. But I think that's a bit of a cop-out, to be honest.
They say the next rover lander up there will look for life in a more direct way. But you would have thought they would have tried for this a long time ago.
Well, people have suggested missions that would follow up on the Viking mission, that would be better than the Viking mission, that would be more sensitive than the Viking mission. So far, they've got nowhere. There are ways of looking for things that might be alive that would be pretty accurate and would be really interesting. I guess maybe their rationale is that if you get a negative result, then it kind of messes up all future missions. Maybe this is a way of kind of prolonging the whole sort of space exploration mission by doing it gently and doing it softly.
Think back a few billion years ago, maybe even a few million years ago. We really don't know. What do you think Mars looked like?
Oh, I think it was wet. I mean, I think there was water, and I really find it hard to believe that there wasn't some kind of, at least microbial life.
Do you think the lakes or the oceans on Mars were as deep as what we have on this planet?
I don't know the geology, the geography of Mars well enough. I don't see why they wouldn't be. I mean, it's not that different to Earth, is it?
No, I don't think so at all. What's so amazing is if it was loaded with water, deep oceans. My God.
Yeah, I mean, anything could have happened. And, of course, we exchange rocks with Mars all the time. There's rocks go out from Mars. An asteroid hits its surface or something, it throws up rocks whose orbit eventually takes them to us, and it happens the other way around. There's just no reason why microbial life shouldn't be on Mars and shouldn't be on, and Mars life shouldn't be on Earth, really.
What do you think of these UFO cases then, Michael? I mean, in Britain, you get a lot of them. They just released your files out there, I think.
Well, we do. I mean, it's just so hard. We don't have the information, do we? We don't have any information. And so part of me wants to think, well, let's keep an open mind. The scientific part of me says, well, you can't comment because you have no information on which to comment. So I'm kind of hedging my bets on that. I mean, it seems to me that if there were, alien civilizations throughout the universe who are actually, visiting, making contact, then there would be harder evidence than there is now. So I'm a UFO skeptic.
But people are seeing strange things.
They are. The trouble is with seeing strange things is there's quite often an explanation that, that does eventually come out.
Yeah, in terms of whether it's ours or yours.
Yeah.
Could be.
Yeah.
Could be. Last night I had somebody from SETI on, Search for Extraterrestrial Intelligence. You mentioned in your book the WOW signal, which they talked about as well, that a long time ago in a far-off place there was an anomaly there that picked up, and you claim that's one of the things that just don't make sense.
Absolutely. I mean, this is kind of, one of those things that just gets dismissed, and we can never know for sure because it hasn't happened again, and all we have is the data from that moment. But, it's there, and there's no explanation for it. And good scientists have spent decades looking for a good explanation. I mean, they've looked for, reflections of aircraft or satellites or space junk or anything, and they can't find any reason why this signal should exist if it didn't come from, beyond our civilization.
What do scientists say behind closed doors about some of these things that just seem to be so unpredictable?
Well, that's an interesting question, actually, because there is a big difference between what scientists will say in public and what they'll say in private.
Yeah.
And, for instance, if you're looking at life on Mars or life elsewhere in the universe, most astronomers or most scientists will take the view that why shouldn't there be life elsewhere? And when they go on the record, they'll say, well, we have no record of life elsewhere, therefore, it's impossible to speculate. But it's, of course, not impossible to speculate, and they do speculate. And I think many of them believe that there is microbial life on Mars. Many believe that there certainly was microbial life on Mars. Things like the WOW signal, people would say, well, that's really, really interesting, and I just don't know. But other things like cold fusion, for instance, this idea that we can release energy nuclear energy without, having a big drama and an explosion. People would say, well, there's something there. There's something going on. And the experiments haven't really got to the point where they can find out what is going on. But I've had, behind closed doors conversations with people, scientists who work at publishing journals, for instance, who said, yes, we think there's something going on, but they just haven't convinced us yet. So, people are more open-minded than you would think from their public sort of espousals of these things.
Do you think that a virus could come and gobble us all up?
You know what? I think it's entirely possible. I was at a conference a few weeks ago, a very interesting conference called Global Catastrophic Risks, and it had kind of some of the world's experts on what could happen to humanity, the things that could wipe out humanity. Mm-hmm. And one of the things that was a prime suspect really in this was bird flu. The avian flu virus. And that kind of took me by surprise a bit, because you kind of, you feel like in this day and age, medicine's got hold of everything, and, we're kind of on top of everything. But actually, a guy called John Oxford, who was presenting this, who's a London professor of microbiology, he's the big expert in the UK on bird flu. And he was saying it's a very scary situation. Now, there's strong, there's good sort of medication, vaccination against this, but actually, if it takes hold, we could be in a lot of trouble.
See, I've always thought it was just governmental malarkey to try to, scare us.
Yeah.
And, for years they've been talking about that.
Yeah.
Still nothing has happened.
Still nothing has happened. Well, what's interesting is that he started off his talk, and he said, I've been listening to all these talks about asteroid impact and supernova, gamma ray bursters that might destroy the Earth. He said the thing is, none of those are up in the UK government's sort of list of things that will wipe out humanity. And he said, and bird flu is up there. So, let's get a bit more down to earth about this.
What other things did they talk about in terms of global catastrophic events and possibilities?
Well, the things that they were talking about were the things that really would, could wipe out humanity.
Asteroids, for example?
Yeah, asteroid impact. I mean, if you've got an asteroid that's above 2 kilometers wide and is on a trajectory that might hit Earth, there's a lot to worry about there. At the moment, we haven't seen one, and we think we've tracked sort of 90% of the asteroids that are sort of heading in or that are in our region. So things are looking pretty positive from that point of view. But yeah, I mean, if a big one hit us, we'd be in a lot of trouble.
Well, it did once, twice, who knows how many times.
This is it, isn't it? You know, the Earth isn't so old. Well, you know, what are we talking, like 4 or 5 billion years? You know, it could happen again. I mean, the fact is now that we have the technology we have the intelligence, certainly, and the technological capabilities to develop something that would deflect this, this potentially killer asteroid. And we need to put some money behind it, I think.
I think so, too. Did any of them talk about the possibility of man-made catastrophes that could kill us?
Yeah, they did. I mean, one of the things is the obvious kind of bioterror thing.
Yes.
Where, you know, we've got the situation where, you know, if the wrong molecules get into the wrong hands, then, you know, you could cause all kinds of havoc. There's also nuclear threats, of course, and, you know, we're facing that again, aren't we, with Georgia and Russia. You know, this idea that, you know, that Russia is quite happily sort of targeting nukes at Poland, you know, really, really worries me. And it's interesting that in the time since that conference, you know, that this has blown up again, because at the conference everyone was saying, well, you know, we're pretty stable now, and the Cold War's over, and all of a sudden this blows up, and you kind of think, well, that shows you how much the experts know. So there's that. I mean, one of the things is that was under discussion was whether you know, big physics experiments could go wrong and destroy the Earth. But the conclusion is no.
Death.
Death.
What is death? You talk about that as being one of those things that just don't make sense.
Yeah. Do you know what? This one surprised me, you know, when I started to look into it, because I thought that death was, you know, kind of an obvious one. But it turns out that nobody really understands why we die. And you can argue that, oh, well, you know, it's just that our bodies kind of degrade and the cells and the organs sort of shut down and it's an inevitable decline. But actually that doesn't really cut it at all, because there are certain animals in which none of this seems to happen. One of them is the Blanding's turtle, which, you know, the oldest known specimen is about 80-odd years old. And it's absolutely fine. There's no signs of aging. You know, still incredibly fertile, just reproducing and reproducing. The bowhead whale is another one. I think the oldest recorded one is 200 years old. And of course, you know, we have no idea how long they live, but they don't get old like us. Their bodies don't shut down. And so, you know, it's possible that we can find some kind of way of maybe copying what they do and prolonging our lives, and perhaps indefinitely.
Do you think, though, that they want to prolong our lives? Seriously? I mean, we're already taxed in this country with Social Security that may go bankrupt one day and things like that, Michael. I'm not sure they really want us to live too long.
Well, I'm sure you're right. In fact, you know, people living longer is the major drain on healthcare systems around the world, isn't it? It's an interesting thing, because here we have a kind of, I don't think there's a huge amount of government money going into this program, but of course there's all kinds of private startups that are researching aging now. There's one in San Francisco called Elixir Pharmaceuticals. It's run by a University of California, San Francisco expert on this called Cynthia Kenyon, and she's discovered switches that allow worms, nematode worms, to live, you know, twice as long as normal. Just genetic switches that you can flip on and off, and they live twice as long as normal. Now, if it's in private hands, the government can't do a thing about it, of course. And, you know, it's quite possible that we will be able to do this. And as you say, you know, completely screw the healthcare systems.
2 more hours to go with you, Michael. One of those will be phone calls. We'll be back in a moment. And our guest tonight, Michael Brooks. We'll be back with Michael as we talk about 13 things that don't make sense next. Michael, about 4 more areas to go, then we'll start questioning you a little more on some of these other things. But
okay.
You talk about SEX as being one of the 13 things that don't make sense.
I do. And
I thought it made a lot of sense.
Well, you know, it makes sense for us, but it doesn't make sense to scientists. And there's a whole litany of biologists who have admitted that they can't really understand why we have sex. Why don't we just clone ourselves? I mean, actually, the main thing in biology is the selfish gene. the idea that every organism basically wants to live forever, and its genes just want to kind of carry on down the generations. Now, if you have sex and you reproduce, then you actually have to share the next generation with somebody else. And that actually doesn't make sense. What's more, if you are in a population where, say, you've got people cloning themselves and you've got people having sex, then people can clone themselves twice as fast. So you get out-competed on every score. And biologists refer to this as the fourfold cost of sex, in that you only have half your genes going to the next generation, and it takes you twice as long to do it.
Every creature does it.
Well, almost every creature does it. I have to say that there is a population of creatures that doesn't do it and hasn't done it for millions of years, and they're doing just fine. They're called rotifers.
Rotices?
Rotifers.
What do they
and
look like?
They're the reason, in a sense, why this is in the book, because people say, well, sex gives you variation and then you can survive in, changing environments. But these rotifers, they have survived for millions of years in changing environments, and they're doing just fine without sex. I'm not advocating that, but, it's there, and it's a real puzzle.
What do these creatures look like?
They're tiny, they're microscopic things. They live in puddles, and if you come across a puddle of water somewhere, you can almost guarantee there'll be rotifers in there. But of course, there are other animals that reproduce without sex. In 2006, there was a Komodo dragon in London Zoo that reproduced by parthenogenesis, which is basically a virgin birth, where you reproduce without having sex. And many reptiles actually kind of swing in and out of sexual and asexual reproduction.
I wonder how happy they are, though.
Well, you know what? The crunch liner for this is they don't need men. They're all females, and they produce only females. And so if we had no sex, then it would be a world without men. And I can't envisage that. Can you?
No, not at all. We'd be gone in a heartbeat, Michael. One of my favorite ones here, free will. You say your decisions are not your own. How come?
Well, when neuroscientists do experiments on the brain, they can show that actually anything that you say is a conscious intention actually is in your brain before you know it's a conscious intention. So experiments have shown that there are kind of milliseconds before you decide you're going to move your arm, they can see that your brain is going to move your arm. And so the argument is that your brain is kind of convincing you that you're making a decision, but actually it's just doing it.
Well, but don't we have the right, though, to decide the direction of our lives?
Well, you could say that you do, but, as we just talked about sex, we have all these drives, and they're, the drive to eat, the drive to reproduce, the drive to do, things that make us happy, the drive to do things that make us prosperous in the long run. And these are, of course, all, kind of mediated by our brain, controlled by our brain, which is effectively, chemistry. It's kind of a few pounds of jelly, but it's chemistry. It's controlled by chemicals, and neuroscientists would say that at what point, where in the brain is this thing that gives you free will? Because they just see a brain controlling a body.
What about now the next one, which is the placebo effect?
Yeah.
Why is that in there?
It's in there because nobody's actually convinced that the placebo effect really works.
And explain what a placebo effect is.
Okay, so a placebo effect is something where it's kind of like the power of positive thinking. So if a doctor tells you, actually, you're going to get loads better, you're in hospital, the doctor tells you everything's going to be all right. Because the doctor has told you that and you trust the doctor and you believe in the doctor, actually what happens is that belief releases or is thought to release chemicals within the brain that actually do make you feel better and do help you get better. So this is the placebo effect, and it can be triggered by anything. It can be triggered by the sight of a doctor in a white coat. It can be triggered by the sight of a needle that's going to give you a pain-relieving injection. All kinds of things can bring on the placebo effect. But nobody's actually sure whether it really does anything or not. It's kind of in there because there are groups of researchers who say the placebo effect has no clinical benefit, and we've done the studies to show that that's the case.
You mean when they study, let's say, new drugs, and they've got half of the people are taking the drugs, the other half are the placebos?
Yeah.
Are you saying that the placebo folks show almost the same kind of numbers as the people, let's say, taking the drugs?
Well, there are studies that show that actually you can have an ineffective drug that does better than whose placebo effect seems to do something more than an effective drug. There are all kinds of kind of mess-ups in the way that we run clinical trials these days. And it's just because we're discovering that the placebo effect is kind of, it's not just that, there is a placebo effect. There are many, many different kinds of placebo effects, many different ways of producing a placebo effect. And these are, and at the same time, we're sort of wondering what effect they really have and whether they have an effect or whether it's just an illusion in our data. So it's kind of a complete mess, actually.
That's fascinating. Okay, in rounding out number 13, homeopathy.
Yeah. This one almost didn't make it in there.
Just squeezed in, huh?
It just squeezed in. And the thing about homeopathy, I don't know whether you're aware, it's this idea that you dilute some kind of drug down, like hundreds of thousands of times in some cases. And you just keep diluting it down until there's probably not even a molecule of that substance left in the water that you've used. But you still, you take the water or you use the water to coat a sugar pill, and then you take that and it makes you better. And this is a kind of principle of homeopathy. And, of course, scientists just hate this idea because, drugs are meant to be chemical. They're meant to interact with the chemistry in your body. And if you're just effectively just taking water, how can that possibly do any good? And yet there are studies that show that there does seem to be some effect with homeopathic remedies.
And natural supplements and things like that.
That's right, and there are many, many people who will say that they've taken homeopathic remedies, and I've met loads of them now, who've taken homeopathic remedies after years of being on antibiotics or something, and actually found themselves a cure that really works.
I swear by it. I mean, I think modern medicine is fantastic, but I think if people have that capability of looking and learning and taking natural substances, which, of course, most drugs are the derivative of, why not?
But does it bother you that what you're taking is effectively water?
Well, I don't know if it's effectively water. Here's an example. They're talking about the spice turmeric, which they say reduces inflammation in your body and your arteries.
Yeah.
I wouldn't call that just water, would you? But I would call that homeopathy.
Well, in some ways, you could argue that that's herbalism, couldn't you? I mean, you could say you're taking a plant.
Absolutely.
But the homeopathic remedies are the ones that have just been diluted down thousands of times. And it seems that, that this kind of principle, it challenges science, certainly. But, there is some evidence that there's something in it.
Well, maybe I see that's why it almost didn't make the list, huh?
It didn't make the list. It almost didn't make the list just because the evidence is slim, and a lot of the evidence is anecdotal. But I still think there's a case to answer here. Are we missing something really fundamental in medicine? If this is the case, then we should investigate this and not just sweep it under the carpet, which is what scientists would want to do.
Overall, what does this tell you? These 13 things that don't make sense. Because you know what? You could have said 50 things and probably could have filled out the list.
I could have done. And what it tells me overall is that science is not done. I mean, people will tell you that scientists are on top of everything now, that pretty much, it's all over, everything's understood. But that's not the case at all. And some of these things have the power to take science back to square one, I think.
See, science can't explain, Michael, why the mother senses that her little child is sick or hurting somewhere through distances, for example. She may pick it up when the kid's at school and not feeling well. Science can't explain that. Science can't explain why, the person didn't go through a green light driving and had this intuitive thought to stop, and someone went right through their red light and would have killed them. Science doesn't explain that.
It's interesting, isn't it? Because science can't deal with things like that. Science just isn't set up to deal with things like that. It deals with things in very carefully controlled circumstances.
Right. It runs from things like that.
Yeah, yeah. I had a bizarre experience when I just got married, and I was at home. I'd just come back from my honeymoon, and I heard the phone ring, and it was at the far end of the house, and my wife was sat by the phone, and she said, "I am not picking that up. You're going to have to come and get it." And she just refused to pick up the phone for no reason. She'd never done this before. And on the other end of the phone was my father, who left home when I was 1, and we'd never spoken for 20 years. And he phoned, and she said, "I can't pick up that phone. It's for you." I mean, how bizarre is that?
That is bizarre. She had no idea.
She had no idea. He'd never been in touch. He'd never phoned before.
How did he find you?
I'm not sure. Do you know what? I've never asked him.
So, I mean, what did he say when he called? Hi.
He said, "Hi, I'm your father." He left when I was 1.
So you were aware that he was gone, right?
I was aware that he was gone. I wrote him a letter when I was 16 or something, and I never heard back. And this was literally the first contact I ever had from him. I don't know how he got my number, but yeah, I mean, that was one of those things in my life where I just think, I don't understand. You know, there was some sense that my wife didn't want to answer the phone, that was for me.
Unless she makes you answer the phone all the time.
She does now.
It's for you. You never. But science doesn't do that. They don't get involved in that, and I wish they would.
That's right. I mean, and science can't deal with like anecdotal stories like I just told you. You know, I mean, and I've come across so many anecdotal stories about homeopathy from people I trust and people I respect. You know, who said actually, you know, there was a friend of mine who had his daughter was stung by a bee, and somebody, you know, ran and her tongue swelled up and she couldn't breathe.
Right.
Somebody went and got a homeopathic remedy that they had in their purse or something that was made from a bee, basically, but it was diluted down and down and down, like I've said, and they put it on her tongue, and her tongue just literally just went back to normal. And he said he was astonished. And he's a scientific guy, and you know, he can't explain it.
What does this tell you, though, about what this could be, where we have, you know, the missing universe. We have anomalies on spacecraft. We are trying to figure out if there's life out there on other planets and other systems. What does that tell you about all these strange things that science can't give us answers for?
I think it's very important for scientists as well as for us to realize that science works within, you know, really quite strict limits. And it works in certain environments, and it works with a certain sort of preconceived set of ideas. And when things don't fit those preconceived sets of ideas, then it kind of really struggles. And I think that's one of the most important things to remember is that, for instance, the missing universe might turn up because, you know, in the 1920s, we made some approximations when we tried to solve Einstein's equations. And we've always lived by those. And we've kind of taken them as being the gospel truth. But actually, maybe science got it wrong in the fundamentals, and we need to revisit that. So, you know, what it says to me is that science, you know, always has to question itself and also always has to realize that it works within limits.
Where do you get your book, 13 Things That Don't Make Sense? Is it out yet?
Yeah, it's on Amazon.com. It's been out a week or so now. So it's also available through a website that I set up for the book, which is 13thingsthatdon'tmakesense.com, which is a kind of discussion forum as well. I mean, there's places there to post your thoughts on all the kind of different things that go on. I mean, my idea is to kind of democratize this a little bit and you know, see what other people have to say apart from the scientists on these subjects.
In a moment, I want to talk about the Large Hadron Collider out there at CERN and get your take on some of those areas. But tell me a little, it'll take just a few minutes to talk about the television program that you're working on with about Stephen Hawking.
Okay, well, it's still in development stage at the moment. It's kind of, as with all TV projects, it's a slow starter. But the idea really is to kind of take Stephen Hawking's view of the universe and set him free, effectively. So the idea might be to animate Stephen Hawking and have him kind of coming out as you know, out of his wheelchair or able to, you know, fly through the universe and just kind of take us through the universe. And that's the kind of basic idea.
What does Hawking find to be one of the most fascinating things about the study of the universe? Did you ever say?
I think his position really is that he he can explore it from his, his wheelchair. He's trapped inside his body, and yet his mind is so kind of able to deal with these things and to cope with the concepts. And in some ways, he's better placed to cope with the concepts behind the universe than people who are able-bodied and able to be distracted by, kind of walking about and doing other things. And he says that he's kind of honed his mind to be able to process thoughts about the universe in a completely different way to everyone else. And I think, he has this struggle to understand. He wants to understand how it works, how the universe came to be, where we came from, the real sort of fundamental questions of life.
Isn't that amazing how he's been able to function and excel? I'd go nuts. Yeah, if I couldn't move or do anything like that.
I think we all think that, don't we? I mean, we all think we'd just go nuts. And I think he's had the kind of strength, the inner strength, to say, well, this is where I am. And he even says things like, actually, I'm quite lucky. Some people get this disease and they die within a year. And I've got this, this extraordinary lease of life. And so he just seems to have no self-pity whatsoever, which I think is just amazing and, something that he deserves a huge amount of respect for.
Well, he's a genius. I mean, his mind is just worth so much to all of us, isn't it?
I mean, the world's a better place with him in it, isn't it?
Yeah, it really is. And he seems like a nice person.
Yeah, that's right. I mean, and he's a very funny person. I mean, he has an incredible sense of humor.
You know what? In some way, I would love to get him on this program, Michael, if you could ever pull that off, even if it's just for a short burst.
Okay.
Well, maybe.
You never know, do you?
No.
I can certainly pass something on to his people.
And, I'm sure through the device we'd be able to hear his thoughts.
Yeah, that's true.
And do that. Where do you go next? What are some of the things you're working on?
Well, I'm doing a lot of work for New Scientist at the moment, just kind of, again, just looking at the frontiers of physics, trying to kind of work out what it is that researchers are trying to, work out and how they're going to do it. And one of the big things that everybody's trying to do at the moment is make a theory where quantum mechanics meets relativity, if you can imagine that. And nobody really understands how to put the two together. We have quantum theory, which is the theory of the very small things, subatomic particles. We have relativity, which describes space and time and how the universe works. And yet the two are fundamentally incompatible. And the biggest sort of quest at the moment is to look into, how do we make these two compatible? And that's one of the things that I'm working on for New Scientist now, is kind of reporting on that.
Do you think we'll ever get to the point where we can do time traveling?
I want to say yes. And, there's nothing in the laws of physics in terms of relativity that say we can't do it. And the only thing is the philosophical thing that we all know is that what happens when you meet yourself if you travel back in time.
The paradox, isn't it?
All the paradoxes. And, this is an interesting thing that Stephen Hawking's talked about, because he's said, well, maybe the paradoxes are a clue that we don't actually have free will. That, we couldn't go back in time and shoot our grandfathers and muck up our own existence. That something would stop us.
It's not that we'd want to.
Not that we'd want to, but there'll be somebody who wants to and see what happens.
Do you know Ronald Mallet?
Yes, I do.
Isn't he something too? I mean,
he's great, isn't he?
Yeah.
What an extraordinary story as well. The man who decided to build a time machine when he was 13 and then worked out how to do it.
And he's getting close. He is getting close. Michael, stay with us. When we come back, we'll talk about the CERN, that collider. Will it destroy the planet? And then I tell you what, because we've got just a half hour to go before we take your phone calls, let's open up the Fast Blasts. I'll take your Fast Blast questions next as well. And our special guest, Michael Brooks. Hey, have you picked up the After Dark newsletter yet, where you get 13 issues for the price of 12? Call 1-888-727-5505. You can also go online on our website, safe and secure, at coasttocoastam.com. And welcome back. We're with Michael Brooks. Michael Todd from British Columbia, Canada calls, Fast Blast me, wants to know what you think about some ghosts. Could they be quantum traces of people from other parallel universes?
Well, that's a theory. This is one of those things where, I don't understand what what kind of remnants would be left of humanity. I said that, we're kind of atoms. I said our brains are kind of lumps of chemicals, effectively. There are no doubt quantum processes going on. I don't think science has any kind of indication that that ghosts are some kind of quantum remnant. But there are strange things in quantum theory that nobody really understands yet. A thing called entanglement, which you might have heard of, which is just this kind of strange link between particles that can exist. Einstein dismissed it and never believed in it, and he just called it spooky because you can have these two particles, quantum particles, put an entanglement link between them, take one to one side of the universe and one to the other, and literally do something to one, and then you can change the other particle from the other side of the universe. And so there are kind of more mysteries out there than I know how to deal with.
Go ahead.
As I was going to say, I can't rule it out. It's, we'd first need to be sure that people were really seeing ghosts, and I'm not sure that anybody's kind of definitively done that. So these things are all up in the air.
The Large Hadron Collider. Is it going to put a hole through the planet, or is it going to eat itself from within? Some believe that.
Some people do believe that, or some people certainly want to believe that. The classic sort of headline is that, a black hole ate my planet.
Yeah.
And it's possible, that this machine, there is a incredibly small possibility this machine could do something extraordinary. But what we have is, for those who don't know what it is, it's a particle collider in Switzerland, where the particles go around a ring that's 27 kilometers around. So what's that? That's kind of 18 miles around this ring. And then they hit each other, and the idea is they smash apart, and they're traveling with such energy that the energy is kind of equivalent to the energies that we saw in the universe at the Big Bang. And so, the particles and the debris that come from that collision will tell us something about the universe in the Big Bang and how things were and what kind of particles existed at that time in our universe's history. Now, the thing is that the energy with which those particles collide is about the same as the energy of a train running at, say like 100 miles an hour. So, a heavy train running 100 miles an hour has a lot of energy, and if it smashes into something, there's going to be a lot of debris. But actually, it's not going to destroy the planet. And that's kind of the argument that physicists are making, is that there just isn't enough energy in this collision to do anything really, really scary, like create a black hole. However, there is a possibility that these collisions will create microscopic and very, very short-lived black holes, because they're not express trains, they're particles smaller than atoms, and so all that energy is concentrated in a very, very small area of space-time. And of course, then you've got the issue that, if you're releasing that much energy in such a small volume of space and time, then maybe, we will get this situation where we create something exotic, like a mini black hole.
Well, they made some mistakes with the collider. Its large magnets fell off its base a few months ago because they did a mathematical error.
That's right.
What concerns me is when you make one mistake, maybe you'll make another.
Yeah, it's always a possibility, isn't it? And, there's no such thing as a free lunch. We don't get to find out more about the universe without taking some risks. But the idea is that, that we've looked at these risks, actually, for a long, long time, and there were concerns over a collider that's in the U.S. at a place called, the collider is called RHIC, and it's on Long Island. And there were concerns that this would create these mini black holes. And so physicists did an exhaustive study of this possibility, and they decided that the risks were absolutely minimal. Nonetheless, you can never say there's zero risk, and nobody can ever have zero risk. And there are good physics reasons to believe that these collisions will quite possibly make sort of very small and very temporary holes in space-time. And, we don't know what that would do. But there is one thing that we do know, is that we get collisions like this happening all the time in the upper atmosphere. We have particles that come from the sun, cosmic rays, and they hit the upper atmosphere above the Earth. and they with energies higher than the energies that will be seen at the Large Hadron Collider. And these have never destroyed the planet, and they've never, maybe they've created black holes. We wouldn't know. If they were very short-lived black holes, we wouldn't know. But they've never sort of done anything catastrophic that we've come across. So, we just have to kind of take this infinitesimally small risk and hope for the best.
And hope for the best. That's the important thing.
Absolutely.
And
I'm not concerned about it, I have to say. I mean, having kind of looked at the studies that have gone on and talked to the people involved, and there was a guy at this the conference that I mentioned on global catastrophic risk, the main guy at CERN in Geneva, who was responsible for the safety studies from this aspect. He was there, and I talked to him about it, and he says, really, there's nothing to worry about. And, it might sound like something that you shouldn't take on trust, but there has to come a point at which we say, these scientists are performing due diligence before they do this kind of thing.
So you're comfortable with what they're doing?
I am comfortable. Yeah, I just don't see how anything catastrophic could really come from this.
Gosh, I hope you're right.
Well, you know what? So do I. In one sense, you could say I'm betting my kids' lives on this. If a black hole ate our planet, that would be the end of everybody. And of course, there'd be nobody around to say sorry to either, would there? So, so in that sense, you can say the physicists would get away with it.
What aspect of science would you like the definitive answer for?
Time travel. I really, really want the definitive answer for time travel. And you know what? I mean, even here, there's the Large Hadron Collider. If it makes this rip in space-time, if it does do that, there is a tiny possibility that time travelers from the future, if they exist, if it's possible, that they could actually use this rip and come back and visit us in 2008. I mean, isn't that an extraordinary possibility? And yet it's there. Nothing in physics says that time travel can't happen. We have these worries about these paradoxes, but I'll quite happily face those paradoxes if I get the chance to travel through time. So for me, I think it would just open up so much of humanity, wouldn't it, to be able to travel through time?
I think so too. What about teleportation?
Again, yeah. I mean, wouldn't that be great? I mean, we've all been on those car journeys where we just think, I wish I could press the magic button and be there now. And the idea of teleportation, of dissembling people, this idea that you could split us up into our constituent atoms and then put us back together again. Now, that seems to me, that's just a technological issue, isn't it? Because, there's nothing sort of fundamental that says you can't do that. And I've said time and time again, we're just a bunch of atoms, really. We're held together by the rules of quantum mechanics. Our brains function by rules of quantum mechanics when you take them down to the molecular level. There's nothing really that says you couldn't take a person and teleport them. But what it means is handling vast amounts of data and information and, an understanding of chemistry. And then you could do it. But, for my money, there's nothing that says you can't do it.
Let me ask you this, Michael. With all these strange anomalies that are out there in this universe, and the areas that we do not have answers for, what happens one day when science comes across some of these answers? Will they change our entire perspective of life, this planet? Even one of these 13, what if they answer these?
Well, I think, to kind of turn your question around in some ways, in looking at the Viking mission in 1976, you could say they did discover life on Mars. They did discover that there was something in the soil that was processing chemicals, nutrients, in exactly the way that we predicted it might. And what I would say is that what will happen is effectively that science will ignore it for a while, for a long while, and until it gets to the point where, you can no longer ignore this. And what has to happen is the evidence has to pile up and up and up, and then scientists have to say, okay, we have to redefine the way we do things. And, this has happened in the past. This happened with relativity. And people knew that there was something wrong with our conception of how space and time work together and how matter and energy, move through space and time. But people shied away from it for decades. There was a guy called, I think it was Henry Poincaré, got really, really close to formulating the equations of relativity that Einstein eventually did. And you know what he did? He turned around and he said, this is just too scary. This changes everything, and I can't face that. And he walked away from it, which is why we now have, Albert Einstein as the father of relativity and not Henry Poincaré. And I think what will happen with, maybe one of these 13 things that's in the book is that, the evidence will pile up and up and up, and scientists will eventually have to deal with it. And some of them will really change the way we see the universe. And I think none more so than the idea of finding life on other planets or making contact with alien civilizations, because that tells us that the same processes that kind of caused us to appear on this planet actually are the same processes that are happening elsewhere in the universe. It kind of changes your perception of what life, is all about and why we exist.
How remarkable will it be on the day we get answers to these incredible things?
It will be unbelievable. It will just be so great. So somebody said that, I think it was Arthur C. Clarke said that if we, maybe there's life on alien worlds and maybe there isn't, either way, it's staggering. And that's what you have to think. If we discover that we are actually alone in the universe, then that tells us something extraordinary about ourselves. And if we discover that the universe is teeming with life and all kinds of other civilizations are out there, we can have meaningful communication with another species for the first time, and that will just be extraordinary. That will be staggering.
I think so, too. I think so. Well, remarkable work you do. Of those scientists that are out there trying to get answers to many of your questions, anybody come to the forefront? Who do you admire out there? Beyond Hawking, of course.
Beyond Hawking, I admire very much the people who are trying to build life from scratch. I think that's a really fundamental kind of thing to try and do. And, there are these guys who are taking chemicals and trying to work out, what it is that makes some chemicals dead and some chemicals are alive. And that is an extraordinarily brave thing to do. And some of them have been accused of playing God or they're going to kind of bring an end to life as we know it. They're going to create something that will take over the earth. But I think it's such a fundamental question that they've really got to, we've got to get to grips with this whole idea of what we are and who we are and where we came from and why we matter. Other people that I really admire, actually, are the cold fusion researchers for a kind of entirely different reason, in that they are ridiculed, basically, in the scientific establishment. And yet, privately, I've had people say to me, I think they might be onto something. And these guys know that they're ridiculed, and they've just carried on doing it because they're fundamentally interested in the science, and they want to get to the bottom of the science of how you might release energy from nuclei without, having to have an atomic bomb explode or something like that. And these guys know that they're a laughingstock in so many ways, and it's a disgrace that they're a laughingstock. I really think that, because science should never have that kind of prejudice. And yet they just carry on doing their work. They plug away and away, and they've been doing it for decades, and they're just starting to get some really interesting results now. And these are people who have done it basically in their own time and on their own money. And you have to admire that kind of commitment to sort of finding out how the universe works.
There are some scientists who, at the same time, really don't care that much about humanity. And I don't know if you'd agree with that or not, but I think they're in their own little world, doing their own little thing. And, I don't think they care much about people.
I think that's definitely true. You can always say there are people who don't care about humanity. There are definitely scientists who just kind of are just getting on with what they're getting on with. And, I can't help but think that, there are people who've kind of lost the point of science in some ways. It should enrich, the experience of being a human being. It should enrich humanity as a whole. And I think, over-specialization has become a big problem in science, in that, we've got people who are researching just the absolute minutiae of how certain things work. And, to be honest, it comes across as quite boring, some of the stuff that scientists do. And I think you kind of lose the sense of what science is for and what science is about.
I think so, too. Well, you know what? Time will tell on so many things.
That's very true.
Are we ahead, we being the United States, are we ahead of most countries when it comes to developing new scientists with great thought, or are we way behind, Michael?
Well, let me tell you, I think the United States is great at importing great scientists. and you'll find...
Because we pay them well.
That's right, you pay them well. And the goal of most scientists who work in most nations is to be able to get a job, at a university in the U.S. because there's funding, and, if you get on the tenure track, then there's good security. But there's just the funding to be able to do good research, and that's one of the great things that the U.S. does. And one of the things that the U.S. has to watch out for is that, its education system has to be, improved in terms of science. I think I don't have the tables in front of me, but I think it lags behind many countries that are, less rich in terms of science education and maths education. And one of the points I raise in my book is that, many of these anomalies, they have to be solved by the next generation, because the current generation of scientists are actually so invested in the current paradigm that they just have no hope of actually being able to think outside the box. And, Charles Darwin even said this when he came up with the theory of evolution by natural selection. He said, I don't expect to convince any of my colleagues, I don't expect to convince anyone who's currently working in biology, but I do expect that the next generation of minds that come up will take these ideas on. And that's exactly what's happened, of course, is that it has become, mainstream science. And so the point I make in my book is that, maybe these problems are not for those who are currently working in science. Maybe they'll never solve them. But, I'd love to see the next generation come up and say, okay, let's tackle these head on. So maybe it's the people who are in high school or in college right now who are going to solve these anomalies for us and change our view of the universe.
Well, that could be, and we shall see. Michael, we're going to take phone calls next hour with you with regards to these various subjects. But if you didn't put a number on the 13 things that don't make sense, how many do you think you could put in there?
Do you know what? I think you could keep looking and just find things in every area of science that actually have been brushed under the carpet. And it depends how much into the detail you want to go. But I'm sure you could just keep looking and finding more and more things that don't make sense. I just don't think we know about many of them, and some of them are hard to find because, of course, these things get brushed under the carpet, ignored, not published, so they just kind of exist as anecdotes. The Pioneer anomaly where these two spacecraft are drifting off course.
Right.
The guy who was leading that mission, this guy called John Anderson, he knew about this 10 years before he told anyone about it because he was so concerned that, there must have been some mistake in some calculation somewhere that he just spent 10 years going over it. And eventually, when he couldn't find an answer, he started to tell people about it, and then it got out, and then it became this enormous phenomenon. Now, I wonder how many other things people aren't talking about.
All right. We'll be back in a moment. We'll take phone calls next hour with Michael Brooks right here on Coast to Coast AM.